In the past 24 hours, OpenAI has dropped a video generation bombshell, and it not only is mind-bendingly beautiful, it points the path towards AGI, or artificial general intelligence, and also shows that Tesla has been on the right path for probably a year or more. Let's take a look. Hey y'all, it's Dr. Know-It-All coming to you fairly early in the morning here, so forgive if my voice is a little rough, and I'm going to try to do this as well as I can because this is really exciting news. OpenAI yesterday dropped a research paper, but along with that, of course, a whole bunch of videos and stuff, so we're going to look at all of those kinds of things. It is called Video Generation Models as World Simulators. You notice that I have that word highlighted, or words, World Simulators highlighted, because that is really the crux of this. Now, I'm going to do a deep dive on what they call Sora here later on, and I don't really want to do that today. Today, I'm more interested in the big picture and how this shows the path towards artificial general intelligence, or AGI, and how Tesla has been doing this for, at least since June, where we saw a research paper presented last year, probably more like a year or a little bit more than a year, according to Walter Isaacson's book. So we've got two completely different companies approaching video generation for two completely different reasons and from two completely different paths, and yet they're converging on the same solution. And my take on this is that that solution is showing us the inklings of artificial general intelligence and embodied AI, even though this doesn't appear to be embodied AI. So first of all, why should you pay any attention to me? Well, I've been researching this since about 2017 or 2018, long before transformers, long before diffusion models. Well, not long before, but in the world of AI, before this kind of stuff. So I've been researching this for 6 or 7 years, and when I saw Sora come out and I saw the technical paper, I was like, oh, this makes perfect sense. And I put that on X. I posted that. I said, oh yeah, this is so logical and what they're doing is so obvious. And people were like, what the hell are you talking about? And I was like, oh, right. Because I've been thinking about this for so long that I was like, this is the path. And actually this syncs up with so much of the research that I've been doing. But one of the big points that they talk about here is scalability of data, scalability of data. Andrej Karpathy and many other people have talked about how data is king. It's really the only thing that matters. The architecture isn't as important as just having tons of data and tons of compute. As a small researcher, I don't have access to that stuff. And by the way, if you want to help my small company out, we definitely need the funding. We are working really hard to compete in this space as well as these big players. And I think we have an angle on all of this, but I would love to talk to you if you have funding sources, because obviously from what we're seeing right here, we need to scale very, very quickly. So get in touch with me. I will leave a link to this directly in the description, along with links to Sora and everything else that I talk about in this video. So anyway, I just wanted to preface things with the fact that I've been thinking about this for a long time. And so this aligns very, very well with my research direction and my thinking about the future. It just happened a lot faster than I thought it was going to. So I'm going to switch back and forth between the online and PDF versions of the research paper, because I can highlight the PDF version of the research paper, but I can't show videos in there. So anyway, I want to talk through just a few, again, high-level things, and then I want to get into why this matters so much. So anyway, first of all, the title, Video Generation Models as World Simulators. It's in the title of the thing. World Simulators implies the ability of this modality to understand the world to some extent. If you look back at the videos that I did on Ashok and Phil's CVPR talks, which I will leave up here and also in the description, because I think it's important that you watch these, you'll see that I talk about world simulation in those videos, or they talk about world simulation in those videos, and I expound upon that. So this is something that we're seeing a convergence from two totally different companies working on this from two different angles, talking about the same thing. And nobody's going to be able to say that Tesla copied anybody else, because of course their research paper was published almost a year ago at this point. Dry January is over, and it's nice once again to be able to enjoy time with friends and a drink or two. But of course, you want to have a great next day too. That's why I love today's sponsor, ZBiotics. ZBiotics allows me to enjoy nights out in moderation while working towards my 2024 goals. ZBiotics Pre-Alcohol Probiotic is the world's first genetically engineered probiotic. It was invented by PhD scientists to tackle rough mornings after drinking. Here's how it works. When you drink, alcohol gets converted into a toxic byproduct in the gut. It's this byproduct and not dehydration that's to blame for your rough next day. ZBiotics Pre-Alcohol Probiotic produces an enzyme to break this byproduct down. It's designed to work like your liver, but in your gut where you need it most. Just remember to drink ZBiotics before drinking alcohol, drink responsibly, and get a good night's sleep to feel your best tomorrow. Go to zbiotics.com/drno or scan the QR code on the screen right now to get 15% off your first order when you use use Dr. No at checkout. You can also sign up for a subscription using my code so you can stay prepared no matter the time or occasion. ZBiotics is backed with a 100% money-back guarantee, so if you're unsatisfied for any reason, they'll refund your money, no questions asked. When my wife Misinformation and I go out for a nice night on the town, I drink a bottle of ZBiotics before hanging out with her and our friends. I stay hydrated between drinks, and the next day I feel great. ZBiotics is a real game changer for those fun nights. Be sure to head to zbiotics.com/drno and use the code DrNo at checkout for 15% off. Thanks to ZBiotics for sponsoring this episode, and now let's get back to it. So let's read this first paragraph. We explore large-scale training of generative models on video data. Specifically, we train text conditional diffusion models jointly on videos and images of variable durations, resolutions, and aspect ratios. We leverage a transformer architecture that operates on space-time patches of video and image latent codes. Our largest model, Sora, is capable of generating a minute of high-fidelity video, which is just crazy. Our results suggest that scaling video generation models is a promising path towards building general-purpose simulators of the physical world. That is pretty remarkable. So again, I read this paragraph and I was like, aha, yep, makes perfect sense, but it probably sounds like a lot of gobbledygook to most people. The big picture thing is here, we're talking about a marriage of transformers and diffusion models. Those are the two big things. Transformers, of course, being ChatGPT, Gemini, Llama, etc. That is taking words and tokenizing them and producing the next word thing. Diffusion models are what is generating images. That's how you see, like if you type in something like, I want a cat in a hat or something like that, it will generate that picture for you. That uses diffusion models. So what we're seeing here is a marriage of those two major directions in AI in the past couple of years. And that, of course, was logical. It was almost inevitable that that was going to happen. And the way that OpenAI has done it is very, very clever. But I'm going to talk about that another day because it's just too in the weeds for what I want to talk about in this video. But the big takeaway here is that what they're talking about is they're creating general purpose simulators of the physical world, not image generators. That is a very, very different direction of research and a very different emergent property that comes out of this training. And that's really what I want to talk about today. So before I go on, here is some eye candy for you. This is a woman walking, the prompt I assume would be a woman walking down the street in Tokyo at night, something like that. You can see that there is incredible motion consistency. If you've ever looked at AI generated images before, they did not have any of this kind of capability. You can also see from this, it is 59 seconds long or 1 minute long. So the amount of consistency over time is really, really remarkable. And of course, OpenAI talks about their problems. We're going to talk about that because I think that's instructive to look at as well. But just the fact that we can get this kind of consistency is amazing. And you can also get it through cuts as well. So here we've got a cut that's like a close-up. That was really good timing, by the way. Did not plan that out. But you can see a cut from a more medium shot to a close-up on her face. And there's consistency between the background. There's a consistency between her look. All of that kind of stuff indicates an incredible knowledge of the physical world in the sense that we humans have it. It's not like solving an equation. It's more like understanding the world. We can path plan. We can think about the world. We can model the world and simulate the world in our heads. And while that's not solving like Newton's equations of motion, it does allow us to interact with the world. And what we're seeing is the same kind of thing happening here with OpenAI's Sora. And then we get to how this works. Sora is a diffusion model given noisy input patches and conditioning information like text prompts, and that's a really big deal. It's trained to predict the original clean patches. That's how diffusion models work. They just have always been done for still frame images. Importantly, Sora is a diffusion transformer. Transformers have demonstrated remarkable scaling properties across a variety of domains, including language modeling, computer vision, and image generation. And of course, that's what we have seen. So again, we've got a marriage of the two major techniques that have been emerging in machine learning research in the past couple of years. And it's a logical outcome of things, but also remarkable in the output quality. Skipping down a ways we read, we find that video models exhibit a number of interesting emergent capabilities when trained at scale. So at scale, that's the data thing. These capabilities enable Sora to simulate some aspects of people, animals, and environments from the physical world. These properties emerge without any explicit inductive biases for 3D objects, etc. They are purely phenomena of scale. And if you go back to the CVPR talks, we get the same thing. What we've got with full self-driving 12, with Tesla's full self-driving 12, is they do not explicitly give it any biases about the world. They don't tell it that the world is 3D. They don't tell it what a stop sign is. They don't tell it what a traffic light is. All of that kind of stuff is learned through the system of taking in a bunch of data, videos, and IMU information, things like that, and just, chunking chunking on it for a really, really long time and understanding what the world is internally and modeling out that world. And here we see OpenAI doing the exact same thing from taking in videos at scale from the internet and training on them. Next up, we read, we find that Sora is often, though not always, able to effectively model both short and long-range dependencies. In other words, consistency over time. For example, our model can persist people, animals, and objects even when they are occluded or leave the frame. Again, think about full self-driving. Likewise, it can generate multiple shots of the same character in a single sample, maintaining their appearance throughout the video. So again, this allows Sora to cut between close-up shots, far away shots, different angle shots. It has to have a really good understanding of the 3D world in order to make cuts like that. Because if you think about that, right, you've got a person who is here and they're maybe a medium shot. So it's like, this kind of thing from your belly button up to your head. And then you cut to another shot that's a long shot. So the person's in full frame and the framing is totally different and it's a different angle or something like that. And then an ECU, an extreme close-up on their face or something. All of that stuff requires an immense amount of understanding of the 3D world. And it's really interesting when I teach animation classes, of course, human beings have to learn how to do this in terms of drawing because it's very easy to make mistakes as a human when you're sort of drawing that stuff out and creating 3D worlds from your imagination. So this is something that is really remarkable and very, very at the forefront of what humans can do in terms of artistic talent. Now, of course, all of us humans can understand and interact with the 3D world because we have built a model of that. But this is really interesting that we're seeing this coming from just video input data and not the physical world. And then unfortunately, we don't get any math or any kind of details about all that stuff because that's not what OpenAI does anymore. But anyway, in the concluding paragraph, they say, Sora currently exhibits numerous limitations as a simulator, and I appreciate that they're, open about this. For example, it does not accurately model the physics of many basic interactions like a glass shattering. Other interactions like eating food do not always yield correct changes in object state. In other words, if you take a bite of a sandwich, there should be a hole in the sandwich where you took the bite, and sometimes that does not appear. And really quickly, let's take a look at this training compute. This is 3 different versions. We have a base level of compute, which produces a result that's creepy as hell. It looks like that movie It, where the thing took over everything. But anyway, when you get 4 times that amount of compute, whatever that amount was, you get something that starts to look reasonable but very fuzzy, doesn't have a lot of details. And then when you get 16x amount of compute, I mean, the framing, the look, the detail, all of that kind of stuff is absolutely beautiful in there. So this is really remarkable stuff they've got going on. And then forgive the fact that the frame is bouncing around up and down here, but the centered thing of the guy eating the hamburger and the person painting a tree, those are really remarkable because you're seeing state changes in the world. So as the guy is eating the burger, you're seeing the burger actually have a bite out of it, and the tree itself has got little, as the person's painting the leaves on the tree, the cherry blossoms or something like that, it's changing that. Apologies, I don't know. OpenAI needs to fix their website because it's just like you can't keep it stationary while the animations are playing, unfortunately. But now let's turn down to some of the problems. So here you can see a glass that's sitting there and it, it doesn't really shatter. The liquid sort of spills out of it magically, things like that. So that is clearly a mistake that's being made and it's not working perfectly yet. And if we go to OpenAI's landing page, you can see a few other issues. We have this one of the guy looking pretty good running on the treadmill, but obviously running backwards instead of forwards. We've also got these foxes, I guess they're foxes anyway, or maybe baby wolves, but they're kind of blending into each other and, it looks very realistic, but they're not consistently there. And then, of course, we've got this basketball, which is, bouncing up in the air and that's supposed to explode when it goes through, boom. But then this other one goes through the basketball hoop and, that's a problem. So that's clearly an issue. And also, where did that other basketball come from? It just sort of appears. And then we've got this one, the most fascinating one. Archaeologists discover a generic plastic chair in the desert, excavating and dusting it with great care. And you can see that it is very broken, but it's broken in a really, really fascinating way. So let's wait for it to recycle at the beginning here. So we've got one chair that's already up, and then there's some sort of plastic wrap or something that comes out of the ground in a very, very unrealistic manner. And then the chair just magically appears. So really, really fascinating issues. And then you can watch as they pick this up that it just sort of magically starts floating and comes out of their hands, and then it looks like it turns into kind of a dog or something like that, but all the while the shadow is very, very realistic and consistent throughout the entire thing. So anyway, let's watch it one more time. you'll see that the problems that are occurring, some people have said that they think it's because the chair is brown or tan colored and the background desert is also brown or tan colored, and that's causing inconsistencies. I don't know about that because I'm seeing the shadow being consistent. I think what we've got is just an inconsistency of organic versus inorganic. Like it's somehow mistaking an inorganic object for an organic object, and maybe I couldn't really tell you why, and probably the researchers at OpenAI don't have a complete indication of this yet. But I think that what we're seeing here is really fascinating evidence of how it's attempting to model the physical world, but not doing it completely correctly yet. But these mistakes show how the physical understanding of the world is not perfect yet, but also shows how when it gets it right, how cool it is that it gets it right. And just real quick, before I get to a discussion of things, I'm going to point out 3 videos that I will link in the description. The first one is about transformers. I did this almost 2 years ago at this point. It talks about natural language transformers and also visual transformers and patches and things like that. So definitely watch that one if you want to know more about transformers. And then we have 2 videos from last year's CVPR 2023. Ashok Eluswamy talks about what I call one model to rule them all, full self-driving version 12, as we later came to find out. And another video where Phil Dwan talks about the foundation model aspect of full self-driving and also the control of Optimus itself. Okay, so what is going on here with Sora, and why do I say it's very much the same as full self-driving version 12? I've already partially explained that, but basically what we've got is we've got a machine learning technique that is learning to model the world, the physical world, again, not in the sense of equations and stuff. Elon has really pointed to the fact that he believes that the true moment of AGI will be when artificial general intelligence can solve a fundamentally new problem, a physics problem, a biology problem, a chemistry problem, something along those lines. That's really interesting, but I think that another way of looking at it is when can it interact with the world as a human being does? Because there's a huge amount of, perhaps not consciousness, because dogs and cats and animals like that, and even very, very simple animals interact with the world appropriately. But in order to build that 3-dimensional understanding of the world and interact with it requires an immense amount of understanding of the universe and the rules of the universe. Again, not mathematically, but intuitively. And I've been arguing all along that you need embodied AI to make that happen. I just did an interview with Suzanne Gildert from Sanctuary AI. If you haven't seen that video, definitely check it out. It's really, really good. We get into the weeds a little bit about embodied AI and AGI and everything. Very fascinating interview, but you might think, wait a second, well, we're seeing OpenAI take a step backwards from that and get to AGI because, again, in order to model the 3-dimensional world to create these consistent videos, it requires a level of artificial general intelligence, of an understanding of the world at an intuitive level, not necessarily a conceptual level in the sense, again, of doing equations, but intuitively understanding the world and how objects relate to each other and the 3-dimensionality of that. And you might say, yeah, look, these are computers, they're not embodied at all, but that is not true because what you're effectively doing by feeding all these videos to this program, to Sora, is you're giving it eyes. You're going like, hey, here, you've got eyeballs now. You can see the world now. It's only a 2-dimensional representation of it, not a 3D one because you don't have stereoscopic vision. Although, who knows, maybe they're feeding 3D videos to this as well. That would be really, really cool. But at the very least, we're seeing like as if you only had one eye and you could see out of one eye, you're getting a 2-dimensional understanding of the world and you're able to begin to put that together. By the way, I think that the chair issue, when we saw the chair collapse and do all kinds of weird things, I think some of that could actually be solved with stereoscopic videos, just a guess on that front, but that would help Sora to understand the world better because it would have stereoscopic understanding of the world as we humans do. Now, is that complete embodiment? No, because it doesn't have ears, it doesn't have proprioception, in other words, understanding where its body is in space because it doesn't have a body. It doesn't have inertial measurement units or IMUs. It doesn't understand how it's moving through the world. All of that kind of stuff is missing, but vision is the way that we primarily interact with the world at a distance from ourselves. And what we're seeing here is that Sora is able to mimic that and to understand the world in a similar fashion. And speaking of stereoscopic view and IMUs and things like that, what has that kind of stuff? Well, Teslas do, right? The vehicles that we drive around have inertial measurement units inside of them that understand how the car is moving through the world and a bunch of cameras around it. So it actually has more than stereoscopic. It's got octoscopic, I guess. It's got got 8 cameras around the car, so it's able to understand the world in a 360-degree sort of manner that videos are never going to be able to give Sora. Unless, of course, OpenAI decides to go into the hardware game, $7 trillion investment, so which they might well do, and who knows that they won't start competing in the humanoid robot and even the auto-driving game, because this kind of stuff sort of shows that OpenAI is actually moving into Tesla's turf a little bit. Now, I don't think they can do it fast enough for it to make any difference, and certainly can't scale up construction, so I don't think they're a competitor, but it is really interesting that OpenAI's Sora, you could think of this as being a prototypical way of creating a full self-driving or autonomous vehicle architecture. And most certainly it could be used in a humanoid robot, that kind of a thing, which is where I think that Sam Altman and OpenAI are really heading. They want to create their own chips. They probably want to create their own humanoid robots or something along the lines, maybe pet-shaped robots, I don't know. But it looks like they're really, really pushing into embodied AI, which gives me a sense of pride that I feel like I'm in the right direction, that everybody is looking towards embodied AI right now. They think that that is the real future. So looking at the research from almost a year ago and kind of projecting what full self-driving is doing, because we don't have a lot of, specific information anymore, it's okay. Eventually we'll get another AI day and we'll get a lot more information, and I'll make a lot of hay out of that. But what we're seeing is that Tesla has been able to do generative frames. They've been able to create frames of the future of driving in that sort of 360-degree world by creating a 3D model of that world. And so what you can do is you can give it like a second of driving video and say, what is the next second going to look like, or the next 5 seconds. And again, remember, we're talking about research presentations from June of 2023, probably based on research from about, February, March, April, so about a year old at this point. So what Tesla has done in the meantime, I don't know, but the likelihood is that they've created this generative AI that's able to project much further into the future with much more accuracy than it was able to do previously. But of course, the data input, the massive data input that Tesla was able to put into that is millions of driving hours, right, of frames, trillions of frames probably, of driving, of people driving around, and it's able to use that input data to create this 3D world, to understand it, to create that 3D world model, and then to move in that 3D world. And what we're seeing is OpenAI feeding videos and also text, and then using transformers on top of this, which Tesla may or may not be doing right now. They're definitely using transformers. I just don't know that they're using it in the same way that OpenAI is doing with Sora. But we're seeing a different sort of path towards the same thing. Consistent video images, consistent generation of what the future would look like. In the case of Sora, that could be with a text prompt, but also with a picture or a piece of video, and it can project forward into the future what that video will look like in the future. So we're seeing Tesla and OpenAI moving towards the same solution here, and it is a really amazing solution, and it really does indicate to me artificial general intelligence, not artificially intelligent agents. As I point out over and over again, this stuff is like a very, very fancy hammer, like orders of magnitude fancy hammer. But what it is not is it is not an agent yet. None of these things, neither Sora nor full self-driving, has its own agency. It doesn't require anything. It doesn't need anything. It's a tool to be used by humans. And thank goodness for that, because the moment we get to artificially intelligent agents is the moment we really have to be scared about. But right now, this stuff is fascinating. It's fascinating. We're seeing a convergence on this stuff, and it really lends credence to what Tesla's been working on. And we don't know what's going on under the hood, of course, with full self-driving 12 yet. But my projection is that they're doing a lot of the stuff that we're seeing with Sora for Tesla vehicles to be able to drive as well as they do with full self-driving 12, at least according to Omar and the very few people who have been able to test full self-driving 12 at this point. So this was supposed to be a very quick look at this, and it turned out to be much longer than I expected. So that's what happens when you get excited about things. Anyway, definitely let me know in the comments what you think, whether you think this is trending towards AGI, whether you think other companies will be able to compete in this space, who is going to be the winner. I think there are going to be multiple winners, not just one. And also what you think the future is going to look like in a year or 5 years or something. It's hard to even imagine at this point, given how rapidly this stuff is improving. And finally, a big thanks once again to ZBiotics for sponsoring today's video. Be sure to check my link in the description to get 15% off your order. And in the meantime, I'll see you in the next one. Bye-bye.